Hello and welcome. This video is going to be focused on standards and semantic layers. It's going to be kind of a two-parter. First part is going to be taking kind of what the other videos have built up on, and as someone who can't read code, how do you get LLM to apply standards to your code base so that once you clean up things, you can avoid the garbage heap entirely. Second part's going to go a lot more technical. I'm going to dig into examples I've seen in code and kind of free flow talk through my thoughts on what I'm seeing with LLM and how it's informing how I have to put together standards for it to output better code off the bat. Because that's the whole deal here. We want good code right off the bat. We don't want to have to iterate through it if at all possible. We can't avoid it, but if we can skip some steps, that's super nice. Again, this is just going to be recorded once. Whatever you get or you're watching, that's what you're getting. So again, I might meander, I might tangent. Do apologize for that, but yeah, let's get into it. So the reason why I did this project vibe code style is I wanted to see, without any guardrails, without any standards whatsoever, what could Claude give me and what would it give me if I iterated through the code. I had a pretty good idea what was going to happen, only because based off how I was going to iterate with it, I had a vague idea based off experience where the code was going to transform to, and knowing and observing how LLMs go through code changes, I had a pretty decent idea where it was going to start breaking down. But I did want to prove that to myself, because maybe I'm wrong. I am more than happy to be wrong. But if I can prove it to myself, then that generally backs up my experience even more, and that informs me how to be more efficient with LLMs going forward. So as I've said, I ran into a wall with this project. It basically hit code complexity with stuff it was changing, where it was just getting harder and harder to change. And so that kind of solidified with me what I need to do with all my projects if I want LLM to generate better code for me, so I never have to look at code. Because like I said, I'm a coder. I don't want to look at code all day. And so if I can just have LLM generate something and generate it well, again, generating what it can do versus generating what it should do are two different things. That's the ideal. Because that'll just get my personal projects and my professional projects faster, because LLM's here to speed us up. But it is a tool we have to configure at this point, from my point of view. So like I said, that's kind of the intro. For the people who can't read code, this is your part. Hopefully it's helpful, but there are caveats to this, so don't just go apply this to your projects, but see if it makes sense for you. So anyway, with my last video, I had left off with, here's my project refactor report. This is Claude looking at the code fresh and telling me these are the big issues it identified based off brittleness and maintainability, because that's what I care about right now. There are obviously more issues to care about, like security, performance, but to get the code out of a bad state, brittleness and maintainability is what I care about right now. So I've started going through that. If you end up looking at this repo, you'll start seeing that I'm just gonna do a commit per item. So here's me having Claude fix the magic numbers. Here was me doing number one, which was breaking up the correlation engine. And here was the this was the reading the JSONs, which is what the previous video is based off of. But the idea here is just to keep track of what item I'm on and what commit represents what item, so that once I get through this whole, or not this one, this whole list, I can run the standards checks again and see, is there anything else big that I need to care about, or is it starting to get in the weeds? So that's just a tidbit if you're watching the repo. But after going through, after going through cleaning up this giant function, and doing the magic numbers cleanup, I've started looking at the code to identify further issues, and I'm starting to see other issues that are going to come up when I run that standards check again. So this is me just based off my experience trying to short circuit it, and that kind of leads to this second part. But anyway, going back to this first part, because I want to keep this vaguely non-technical. Once you have identified once you have Claude identify big things, what you can actually do to potentially stop Claude or other LLMs from doing this in the future, it's not 100% going to stop it, but it is a nudge in the right direction. What you can do, and this is what I've done, I had it do some cleanup for the big one, and then, here we go. I had it do the cleanup for the correlation engine, and then I prompted it and said, based off what you saw and cleaned up, and based off the project refactor doc that you read, add some high-level coding standard LLMs need to follow to keep clean code. And so what this did was Claude took that and outputted it to my Claude. And so the idea is when other sessions load, it will load this file by default, and this will get inserted into the context window, so that when Claude is writing new stuff, this will be in the back of its mind and kind of push it in one direction versus another. The caveat being, when it's editing code, it will follow this much less, because when you're creating something, there is no structure, and so what is documented is what Claude focuses on to structure it. But if Claude is editing stuff, there's already a structure in place, and it is more efficient for it to just stick with the structure than completely refactor it to a new structure. And this is what devs do too. They're editing code, they will opt to just change the code in the least possible way possible, because if they clean up and do feature at the same time, it can lead to a refactor mess. It can lead to a lot more regression testing. So generally when we as devs go into files, we'll look at the file and make a decision call of, is there anything I can clean up without affecting my feature? Or do I need to make a ticket as a tech debt ticket and say, this really needs to be cleaned up, but I'm not going to do it with my feature work because it slows everybody down. And that's how I perceive Claude working as well, between making new things and editing things. With another caveat being, if it's going into a file and making a new function or a new group of code, that's technically editing something, not creating something, because again, it's reading a file, it's seeing its structure, and it's basing its new code off that structure, not off the standards that might be in its Claude file. So high level, or to wrap all this explanation up, from my observation, that's the big distinction I've noticed. Even if you put this in place, it is going to make judgment calls depending on what its task is. And if it's getting stuck in a debugging loop, or it breaks something, tries to fix it, and breaks something else, that's when it starts abandoning standards as well, just to get the thing done. There is efficiency in it, but that's why you kind of got to watch it. So So like I said, what I did was I went through one cleanup, and then I told Claude to just give me bare bones, common standards of what good code might look like. And so it generated this for me. What it generates is going to be dependent on what it identified and what project type you're doing. Like if you're doing a Java project, this Node.js doesn't apply to it and will just be confusing. So all this to say, if you look at this in the repo, don't just copy this, because you don't want to confuse Claude with technology you're not using. If you use this in a Java project, it might ping Claude into thinking it needs to now add Node.js, which is a very different technology. So knowing people who watch these videos and trying to just cut corners, which I completely understand, don't just copy this if you go find it in my repo. You need to generate this based off the project you're working on, because what it generates matters very explicitly to what is in your code. So that's why I'm showing you how to prompt it, not giving you the standards. So like I said, I had it generate these standards. These all vaguely look correct. From my experience, I might tweak some of these. For instance, code coverage. I need this to be a lot more explicit. And in another repo, which I also have on GitLab, my standards for how it writes tests and what it covers is very different. And this is all just based off my experience of what I need tests to cover versus what I've seen Claude generate if I don't tell it explicitly this. So, to surmise, I try to just do free flow vibing. From my experience, I know where this is going to slow me down. So I am just short circuiting and saying, any project I do just needs standards. I do not necessarily like this, because if the LLM gets better, it might be able to do some of this without me prompting. So if I add this to my repos, I now have to check it every now and then and say, if I remove this stuff, will Claude or whatever LLM run into and do these things again? And so while this is good in the short term, it can lead to a liability and maintainability. So those are the caveats. Don't copy what I have here. Prompt Claude to give you what you want. And then if you do this, just know these are the rules Claude now has to follow. Better LLMs might not need this, so it might just become context waste. So you do have to just watch these as time goes on, because eventually LLMs will be so good at this that we don't need to dictate. Don't do any. Keep the strict mode. Like, these are givens for any developer that works on a project, but for some reason we still have to tell Claude and LLMs to avoid these. So that's the whole spiel with that. I think there was one other part. Yes, so it gave me the full standards. I actually had it do one other thing, and this is what I'm going to talk about in the second part. But this is just a heads up that I had it generate because I didn't want to have to write all these, but then I took the generation and I'm going to start tweaking it to get it to where I need it from my experience level. So from a non-techie perspective, you can have Claude generate these, and this will guide your projects further and help you avoid the garbage pile a bit more. But it's not guaranteed to do that, as I've explained. And then for the other bit here, so I have an example of I've had Claude clean up a big file, as we were seeing in the output here. It was basically splitting a big code file into better pieces for me. And even though it did this, it caused potential future other issues, and I only know this because this is based off my experience. So this isn't so much a you'll be able to recognize this if you don't read code. This is just to say, even if you have Claude do these cleanups, like I've said before, this isn't a one-off thing. You have to do this on a consistent basis, because it's like peeling layers of an onion. Claude can only focus on so much, so it's going to focus on the big things it understands is big, and then if you run it again, it's going to go a little bit more granular. Case in point, this thing right here. To keep it non-technical, this is just bad. This will not scale. Basically, if I tell Claude that I need something fixed and it sees this, it's just going to tack onto this. And it is very possible for it to end up with 15 of these, where even this many of 8 is just not maintainable. So Claude did clean up for me, but he cleaned up this in such a way where this now has a new cleanup issue that will become a problem in the future. Again, if you can't read code, if this happens in the short term, it's fine. But just understand this is why you have to run these standards checks every now and then. Because if I run another, in fact, I did run another Claude. So I added, let's see, this is a standards, yeah. So I had Claude generate my standards based off what it's seen, and then what I said is I prompted a new session, look for brittleness, maintainabilities, and code standard issues. So now that I have coding standard issues documented, I can now prompt Claude to go look for things and find if new things show up. So even if Claude coding something might not follow these, it's a way to just give reviewer Claude things to look for and catch on a more consistent basis. So what I've said is look for these 3 things. If you identify stuff, put it in a document. If not, just say so. By doing this, it will allow it to not look for things that aren't issues. It gives it an escape hatch, basically. So generally, if you're going to have it look for issues and you've done this multiple times, this is when you want to start telling Claude, if you don't find anything, that's fine, just say so. And then it won't try to find issues which aren't there. And then think as you go, just gives it a little bit more processing to not hallucinate as much, but it will still potentially hallucinate. So I gave it this prompt to say, go look for these 2 things I've been looking for, and then go look for our standards. And then I forgot to specify that I wanted in layman's terms, so it actually gave me one that was very technical. I could still feed that into Claude, but if you're looking at reading these, let's see, you want to specify. So where's my prompt? Oh, there we go. I realized I didn't specify that. Oh, okay, sorry, I'm getting confused. I had run this the first time without layman's. It generated something that I didn't want, so I killed the session and started over. So this one generated in layman's. So what we got was this one. And it identified stuff that is in my standards and also not in my standards. Unreliable, multiple to... Yeah, so I'm not going to go into these. These get a little granular. Wait, sorry. Wow, I'm getting confused today. One shot is for this one. I'll explain this one in a minute. But basically, here's the doing too much. If it finds a standard, it will generally say this is the standard. And here's our brittleness issue. So it generated some stuff for me to now do another Claude session, go through to clean up more stuff. But the thing I wanted to point out was with how I prompted this, it kind of looked for all issues at once. As I've said in another video, if it finds enough issues, it's just going to stop finding more because it has some internal token efficiency processing stuff. So what I did was I actually changed my prompt and I said Uh, sorry. This is the one that was... okay, I'll just wait. Yeah. So I changed my prompt, and I said, do the same checks, but in this case I said do one wave per to-do. So I wanted it to check for brittleness, then maintainability, then coding standards. And then again, if you find some, output them. And in this case, it actually listened to what I said because I structured my prompt a little better. And it actually did the first wave, it outputted. It did the next wave, it outputted, and blah, 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 blah. And so what this actually gave me was, it is a more granular doc, and it finds more things, and it gets us past kind of that token efficiency thing. Because this is no longer a one-shot response. By having it do to-dos, it turns it into a multi-shot response, which gives it a little bit more wiggle room to be a little bit more systematic. What this does, though, with how I prompted it, is it will find duplicate things. Fragile data structure. Here's it talking about 8 different parameters, which is what we were looking at here in wave 2, which is maintainability issues, but also in wave 3, which is explicitly calling out don't do too many args. It found it again. And I actually like that it duplicated it, because now I know it for sure looked at only standards generically and then looked at coding standards. Which tells me that it was a bit more systematic. So what I could do, if I don't like the duplicates, I can just have Claude now clean this up. But all that to say, this is an example of, depending how you prompt it, given these kind of token efficiency things baked into the LLMs, the level of detail you'll get is very different. So you kind of have to prompt around this if you're looking... because this one-shot prompt is fine, it gives me issues, but I have to go through these and then prompt again. If I can get it to be more detailed off the bat, I might still run another standards wave, but it's the difference between running it 2 times versus 5. So, again, for the people who can't read code, like I've said, it's going to generate stuff. If you want to read through it and try to understand it, absolutely. It will serve you in the future. But if you don't, now you have a report, you can just point another Claude session and do one of these per session, like I said, but just point it to it and just say, go fix this. And this is how we don't get good code right off the bat, but this is how we scale to better code overall and keep from turning into a garbage pile again. Because that's all we care about. It doesn't matter what the code is, but it does when you have to iterate on the code. And so garbage pile is bad. Avoid the garbage pile, I guess is what I'm saying. So that's all to say. That's the non-techie stuff. I'm now going to go into semantic layering. And this is more of a technical observation of how to get better code out of LLM right off the bat. So for those who can't read code, by all means stick around if you're curious, but this is going to start going into code, and this is going to get pretty technical, but if you can understand it, it will help you in your project. So disclaimer given. Let's go through these. So let's see, semantic, how do I phrase this? So from what I've seen with code being generated from LM, and from what I've seen as I watch it make changes, I'm starting to get a sense of, and I've said this in another video, the more semantic layers it has to deal with to go from point A to point B, the more issue or the more inconsistency you're going to run into with output. And if we flip that around, we can then say the less semantic layers we have to, that an LLM has to deal with, the more consistent results we'll get. And that's the goal here. If we can consistently get it to not assume things and give us good code right off the bat, the less we have to review, the cleaner the code will be, and the more it will speed us up in the future. And I have some very specific examples of this to kind of to frame this conversation. So I'm going to preface this. This is all based off my observation with working with LLMs. These are based off my experience of this has bitten me in the butt too much that now I avoid this. And this is why this comes off as a very bad thing that I now need to get LLMs to avoid. But everybody's experience is different. Everybody's expertise is different. And more importantly, everybody's opinion on good code is very, very different. So I agree, while I agree with certain standards and I avoid them for reasons that I've had issues with them in the past, it doesn't mean they're not valid, and it doesn't mean that I'm right either way. These are just observations I have that are informing me of what standards I need to give LLM to get better code in less terms than if I don't standardize. So when I started this, and I am starting to ramble, so I do apologize. When I started this video, like I said, I didn't want to constrain LLM. I didn't want to put standards because I hate having to put these together for on a per project basis. But with this project, I have come to the unfortunate necessity that currently LLMs need standards. They need some kind of guiding post, and even if we have this, it's still not going to work in every situation, but it's better than not having them. So this is why I've now had LLM generate standards for this project, so I can now see, are these too many standards? Because I don't want to have to over-standardify it or overdo too many standards because it clogs the context window. So at this point, I'm playing a balancing game of what's the least I have to give LLM to get the most out of it, and then figure out where the diminishing return is and kind of tweak it that way. So that's how I'm approaching kind of optimizing LLM output, given that LLM is such a non-deterministic technology. And I do understand that because it's non-deterministic, I can't just tweak this and call it good. I have to get multiple sets of results to see if it's good before I can say it's good. So that's kind of where I'm looking at as I'm working with LLMs to get to a point where, like I said, I don't have to look at the code. I don't have to worry about the code. There's other things I'm doing in other places where I have code reviews set up and I'm judging if that's good enough to where I don't have to code review. But from what I'm observing, this is a layered process. LLM generating code is the first draft and it has to go through multiple reviews. But if it goes through multiple reviews, like 2 or 3 reviewers, generally it's looking better than if it was just to one-shot it. And if I can get a comfort level of, okay, if I can send it through 2 different review layers, and maybe it won't be perfect, but it will get me much closer and prod ready than if I didn't do it, that then tells me, okay, these are what I need from a quality assurance level, and that then informs me what I can generate with assurance from LLM and what I still need to watch for. And there's never going to be I can't just, well, the ideal is to never look at code, but that ideal is very far off if at all feasible. So I'm being realistic and ideal here at the same time. Anyway, getting to examples. So let's see, we went through the one-shot stuff. Let's see, process message, and that's in the message parser. So as I talked about earlier, this thing, I had Claude clean up code and it made this thing. If we're talking about semantics, This comes down to usage. So if I go find usage and I say here, what works with LLM is what you load before you have the task. So if what matters is what you load into context before you have it work on the task. So for instance, I've given Claude a task to go code something, and it didn't pull types, and so what it generated was a very loosey any type code. But then what I did was I just said go explicitly read our type and then go do this task. It actually used the types because it, one, had them in context, and two, for some reason there's some kind of indirect semantic something where when you tell it to go do a task, it doesn't always think to go look at what types it has. Sometimes it does, sometimes it doesn't. So there's two levels here. Understanding what it needs to generate good code, and understanding when there's too many semantic layers where it's going to mess up. So I have an example of quote unquote too many layers, but this is an example of enough layers, but it gets confused. So if we look at this as developers, this just looks bad. You should never have 8 args in a sequential nature. When you have to do this, you need to switch to object arguments. And how this applies into semantics, if it's just one by one, in our IDE, we have what these mean. But when a LLM is processing this file, it sees these 8 arguments, and it's generally just going to make correlations of what they mean based off this file. So if I tell it to go use this function in another place, in all likelihood, it's just going to look at this and say, I vaguely understand enough to where I can copy it, and it might not actually go read the function and figure out what these things actually mean. And we can see this get worse if you go into the tests. So if we go into message parser, again, my IDE tells me this is time gap of 0. But if I tell LLM to go make sure I have all my test cases, it will read this file, but it might not necessarily make the correlation that time gap is, or let me rephrase this. If I have it write tests, it's going to read this file and it's going to understand time gap. But if it's using it in code and it's in a file that's using this, if this is named badly, as in if it's editing code that a dev has touched and the dev didn't do good naming, it might misunderstand what this is, but not think that it has to go look at this because we don't have the name of this thing. So if I were to go change this to Gappy, if an LLM is parsing this file, it's going to read this and be like, okay, message session ID Gappy. It's going to look at this, but it doesn't tell it what might be happening with this variable to know what it needs to send in versus it not. Whereas if we force a object notation for the argument, oops, and I'm just going to do this. This is then going to force LLM, when it uses this function, to use the argument names as it's required by the function. So, time gap. And I'm not going to finish this, but you get the point. This gives it extra semantic information that it may get confused with if it's not an argument, function argument, as if it's just sequential arguments like this. So all this to say, this is technically a little bit more overhead from a token perspective, but this then gives it a little bit more context in case it doesn't read the file when it's using this. And this is just more of a tip of if LLM is working on dev code, this is where it's going to struggle the most, because devs, depending on the dev, don't do good names. Let's just put it that way. Sometimes they do, but sometimes they just get lazy. Let's just put it that way. So this is one of those, with this setup, there's an extra semantic layer that's now relying on the LLM to rectify before it does your task. Whereas this structure, it gives a little bit more information in the file it's parsing to not necessarily get rid of the layer, but decrease the layer girth. If this is a girth of three layers, this is maybe a girth of 2. And as we know, LLMs all work in very minute numbers, so that 1 octave or whatever it is makes a difference. It doesn't make a big difference, but yes, that's all I'm going to say on that. The other point of this is iterating and maintainability. As I've said, if this structure is in place and it's told to go do something, it's just going to tack on here. It's not going to stop and say, this is too many arguments. So the other benefit of basically forcing LLM to do object arguments for everything is this will maintain and iterate better than this. Because if we then, in a feature, say, okay, this is actually optional, when LLMs go use this, it's easier for them to exclude it from the arg than to then go find all instances of this if it's not an object argument and go change it. So this structure here is more flexible to maintenance and iteration than this is, as we all know as devs. And trust me, people, even devs, just tack on. And yeah, so at my job, I generally have a flexible standard and say, if you have 2 arguments, you can do sequential like this. But once you get to 3, you have to switch it to an object argument. And even with that standard, people still try to do it sequentially. It's just the nature. We all know why this is. It's what it is. So at this point with LLM, because I know this will grow better than this informs my standard to say every function, even if it's a little bit more boilerplate, needs to be an object structure, not here. Because if I make a standard and say, tell the LLM 1 and 2 is fine to be sequential, but then you have to switch it to 3, it will not switch it every time. It will just add to 3, and then I have to go through a standard cycle and have it clean it up. So me personally, to avoid the maintenance toil of something like this growing, because I know vaguely how LLM's going to process this and work with it, I am moving towards the standard of everything needs to be a function arg, or an object arg, and that's what's informing my standard. I rambled there, so I do apologize, but that's what I'm seeing from a semantic layer with this, and this is why with LLM standards, whereas traditionally I would be a little more flexible with devs and say make this decision based off best practice. With LLMs, I'm not giving them the flexibility of that. It's cut and dry. You need to do this every time. It does make more boilerplate, but the standards I put together are from the perspective of everything will grow, and so I need to prepare for everything growing so that LLM can code effectively in the code base. So that's an example of why I had, and see, even Claude wrote this wrong. It said 3+ parameters do an object destruction, and I'm saying, no, all functions, function parameters must use object destructuring. And that's an example of Claude. Yeah, anyway, that's the example. I'm going to move on. I'm rambling at this point. So the next one, and this is what I've seen when I have it, this is where I started seeing the semantic layering to where I need to start paying attention to this. So in a code base, I'm not going to say where, we had this const where country codes, it was named, and it had this translation. This is a bad name. I hope we can see why. If this is used, and you go into code, this is what you're going to see. And this is what an LLM will see. If I'm in an IDE, I can roll over this, and maybe I'll see the value if I do as const. Maybe? Yes. But an LLM, when it processes this file, isn't going to see that. It's just going to see US. And the assumption here is country codes US, it means the value is also US. Because that's the most logical assumption. So when I had LLM writing tests for a file that was doing this, the LLM did the expect as string US. And that failed the test, because the string is actually United States. This isn't a big thing. It got around it. It realized it's broken. It went and looked it up. But the point here is the setup wasn't optimal. It slowed it down. It had to spend more turns to fix it. And this is a very clear example of there's an extra semantic layer baked into this setup by virtue of saying this key is actually this value, not US. Now granted, something like this setup is actually what we need when we have to translate for display. But the name combined with this kind of setup leads LLMs down a different path than if you were to be more clear and say something like country codes to country names. Just by doing this, this should give LLMs enough context to show that there's a translation layer happening, and it might then actually go look at this thing before it uses it. Or it can read this name and say, okay, country code to country names. That means when this loads, it's probably going to be United States from semantic context. So all that to say, what I think is going to happen with our code is we're going to have to start identifying these kind of implicit semantic layerings and figure out from a gut perspective or something, because I don't know how to explain this in a rule-based setup, that this has a semantic layering of rating of 7 versus this have 5. I don't know how to put that together. But this is what I'm noticing, to where if we want efficient code from LLM, we need to give it enough context in the file it's in, with the assumption that it doesn't have an IDE mapper like we do as devs. And it's going to make assumptions based on semantics and think it's right, and then it's just going to cause more turn burning to get it right properly. So this might mean that we now have to say our namings are more explicit to give context within the file to the LLMs to be successful. This kind of goes into imports as well. Like, let's just say, let's just rename it to codes. Why the heck not? And let's keep the file name actually the same. So if I go back here and rename to country codes, and I don't want to change the variable. What has been some devs' opinion is the import gives you context of this so that we can keep this export a short name. And this is problematic for devs and LLMs. I understand why people would say this is good, but it's even worse for LLMs now, because they because depending on their task, they're not going to read the whole file. They're going to go do a grep and they're going to do partial finds. And if they go and partially find something like this from line plus 10 to plus or minus 10 to plus 10, it's not going to see that import. And so it's not going to have more context of codes as actually country codes. It's just going to see codes of US and have to make semantic leaps of what this is. And again, it might go look it up, it might not, depending how confident it is of what it understands this to be. So all this to say, if we as devs have been relying on import names or import file names to add context to our variables, it's just not going to work with LLM. Every time it has to make code, it's not going to read the file every time. It just won't. It's trying to save tokens or whatever. So you can prompt it, but you're going to have to prompt it very explicitly every time, and it gets very obnoxious. And this is why I'm saying every line of code almost needs to have enough context to where nobody has to go look at another line of code. I know this sounds really weird and really bad under certain circumstances, but I'm trying to say this is a guiding principle I'm starting to adopt as a dev, not as a hardcore, this is what we now have to do. I've always hated, as a preference, because I always get messed up with relying on the file name to be extra context. This stuff gets collapsed in imports, and I'm not going to look at an import to get more context of the variable. I need the variable to have the context I need on the line I need it, so I don't have to go looking for it. So all this to say, and I keep saying all this to say, this devs suffer from this, and LLMs suffer from this worse. So yeah, that's the example of that. Let's see what else we got. Linting, yes, linting. Line 112. 112. Am I? No, I'm not. I need the file not test. Okie dokie. Yes. So this is another example of we as devs in IDs have more context because our IDs pull it in. LMs don't have this context. When it reads this line, it doesn't, unless it's read the type of response, it doesn't know what response is. And in this case, it doesn't know the type, so it put any here, and it got back any. And so this is where linting is now going to become necessary if it's not already. Like, it should be necessary, but if you're not using linting in your projects, you need to. I've tried to avoid it because, again, I wanted a very light setup to see, can AI give me good enough code, maybe not great code, but good enough code to where it can just be good. I've hooked up lint to post-hook rules in Claude because it was missing running it at the end. So I was like, okay, why don't I do a post-edit hook and tell LLM, look, you made all these lint rule errors. And what that did was that blew up my context and ended the context window much faster. So what I was hoping to say for this project was, okay, I'm not going to set up any linting and just see where it goes. Because a lot of linting rules are opinion-based. We do it so the code can be consistent and we can look at it. But there are some linting rules that are going to need to be in place. For instance, if you have TypeScript, there's some linting rules that say if this equates to type any implicitly, throw a lint error. I can't get this in TypeScript in the config, so I actually had to go to lint to get this to enable. And what that allowed me to say was type any is never ever allowed. And what this does is this then forces LLM to say, if it does something like this, to stop it and make it fix it before it moves on. And that's how I am basically forcing LLM into a very small box as it codes to get better results as it codes stuff. Now this isn't optimal. This forces it to stop and fix something before it continues, and this will cause more churn in its terms as it goes through the session. But I much prefer it to make clean code as it writes it than have to fix it at the end. Because if it fixes it at the end, it's then just going to start doing even more gross garbage code to get through to get the compiler to run. And this is where we end up with it trying to disable lint. And that's bad. I shouldn't have to say why that's bad. That's why I had to put a pre-hook on to stop it from turning off lint on the linting file. So all this to say, and now I'm just reiterating, all this to say, linting is required, at least for TypeScript projects, if you want good output from LLM. And you have to almost tell it earlier rather than later. Otherwise, it will cut corners. It will just cut corners. The closer it is to auto compacting, which is about 155K, and it seems to know this now. It seems to start cutting itself off, or something is telling it to wrap it up when it gets closer to this window. It's a good thing that Anthropic is doing, because it stops it from getting compacted halfway through. But it also means that we now have to be cognizant of how quickly the context window is going to grow, and at what point in a task will LLM be at, and how big will the context window be when it gets there. For instance, if we have it code, then test, then run lint and build, depending on the task, lint and build will probably be, lint and build checks will probably be at like 130K context, depending what's in there. And at that point, it will start cutting corners. Like if it runs into any issues with lint and build, it might attempt to fix it, but once it attempts to fix it and it still fails, or it fixes it and causes another issue because it wasn't paying attention, it's then going to start trying to disable those rules because it's getting really close to that cutoff. So I was hoping not to do linting with personal projects because it's a bit of a pain to hook up, and it causes Claude and LLMs to cycle longer on the same code. But if I don't do that, I get crap like this, and this just snowballs. And type any in this kind of project is unacceptable. This is just a liability. So if you don't want to do linting for personal projects, you might have to. That's all I'm saying. I have to at this point. I'm going to have to put this in. One last example. I'm going really long. I do apologize. One last example, and this has to do with types. Again, I just wanted to give LLM freedom of just code as it feels most natural. And as most natural, it puts the type in the file. This makes sense. It gives it the context it needs to do the file. This doesn't maintain well, because as soon as this type needs to be used, which it does, like in this message parser, now if it was going to go change this, it might have to read this whole file. And if it reads this whole file and doesn't read the first 50 lines, it's going to get more context that might confuse it. And also, this doesn't maintain well. If this file needs 10 types and it puts them all at the top of the file, that's a lot of context window for that file. Granted, it needs the types, it needs to go in the context window, but it makes the file longer. And there seems to be, after about 1,000 lines, LLMs will not read more than that under certain circumstances. To where we have to add a lint rule that says files can't be more than 500 lines or 1,000 lines, depending on the file type, because tests get longer. Which means now we have to be cognizant of what it puts in these files. So this is all to say, like, as projects grow, we know this. Types have to be consolidated somewhere special. Because even if today a type isn't used outside this file, inevitably it will be. Like, it's just a maintenance inevitability that happens. So we always, at least in all my projects, we always move types to their own folder. What this relates to with what I talked about earlier is if you tell LLM to go do something, unless you explicitly tell it go read types when you go do this, it's up in the air whether it will go do that. And if it doesn't go do that, that's when you get type any, at least for TypeScript projects. So all this to say, we have to put in it looks like we have to put in a standard. We have to establish some kind of structure for LLM if we don't want to run into the maintenance stuff we usually do. And if we move these into where they usually go in their own files or whatever, we now have to make sure to tell LLM, go read this when you do any tasks. Otherwise, it's going to be up in the air whether it does it, and then it goes to any, and then we're back to where we are. So, yeah, that's the gist of that. So, to surmise, again, this is just what I'm seeing with LLM as I work through it. These were my ideals that I now have to be realistic about. I hate it. I don't want to have to dictate this to LLMs, but as the models stand currently, they are very task-oriented. And like I said, what it can do is not what it should do. And we all know this as we maintain projects. So, only what I've observed. Again, you might observe something differently. This is just what's pushing my standards. Hopefully it's helpful. If it's not, thanks for sticking around for so long. I did ramble. So, thanks.